Hello, Professor. My name is Gu Qi. This is my work for the course Computational Mathematics 2. My research topic is the research and application on highlight line of curved surface quality evaluation based on the three-dimensional assembly environment. I prepare the four parts for my presentation. The first one is the problem statement. The second is the theoretical basis of curves. The third is analysis and application. The last one is conclusions. The first one is the problem statement. In this part, we know with the improvement of living standards, people's demand for the products is no longer limited to the quality of products. The aesthetic and humanized embodiment of the design of industry products will not only help the products to spread quickly and widely, but also bring more added values to the products. Therefore, the sharp design of industrial products, especially the design quality of curves and surface, is attracting more and more attention for products design. Curve and surface quality analysis is widely used in the automobile, ship, car, aircraft, clothing design, and other fields. However, traditional curve and surface quality inspection is often time-consuming, and the reliability of inspection results is not high. For example, in the design phase of car body, the model is often used to repair the curve repeatedly. The approximate smooth curve is achieved, and the contour curve is often drawn in the inspection stage, and the curve quality is observed through the experience of the professional discharge operator. The part 2 is the theoretical base of curve and surface. This part we have to introduce some mathematical methods. The first one is the Bezier curve and surface. Bezier as a parameter curve first appeared in computer curve construction, was put forward by French engineer Peter Bezier in 1962. In a given space, the location vector pk of m at one point, then the parameter inequality of the Bezier curve is as follows. Among them, P is a Galacticus pigeon that forms the Bezier curve. Is then Bezier function is like this picture. By defining the Bezier curve above, we can give the definition of the Bezier surface in the form of tensor products and set P in the two dimensions, just as this follows. Second is the B symbolized curve and surface. B symbolized curves and the surface can inherit the good properties of Bezier curves and the surface, and solve the problem that Bezier curves and surface are difficult to be partially adjusted. The parameter equation of the B symbolized curve is as follows. In this form, this is the number k control point of the curve. is a function. D is the number of B-spline curves. According to the Billion curve resolve definition commonly accepted by B-spline curves, it best function as the generation as this picture. Therefore, the parameter equation of the B-spline surface we can order might be like this. The third method is a non-uniform rational B-spline curves and surface. Non-uniform rational B-splines, just as NURBS, is an excellent modeling method for curve and surface. NURBS surface is an generalization of B-spline surface. Its parametric equation is as follows. In the formula, the point P is the control point of the surface, and omega is the weight line vector associated with the control point of point P. And in the last of this part, we need to define the class A surface. The term A-level surface starts from the automotive industry and first proposed by Dassault in France. At present, the space indicators are like this. The position between the adjacent surface graph below 0.005 millimeter, cut rate changed below 0.0052, coverage change within 0.5 millimeter. In the construction of NURBS curve and surface, the control point of the surface and the curve are empowered according to the different importance, so that the control points are arranged in a uniform or a non-uniform layout with weight in space, so as to achieve the idealized control of the adjustment surface. NURBS can achieve better surface modeling than before. And the International Organization for Standardization also defined NURBS as the only mathematical method of the geometrical shape of industry products. And the B-spline construction are also integrated into NURBS. So at present, the splines created in the mainstream 3-dimension computer aided design are all NURBS. The third part is the analysis of surface quality highlight method in the assembling environment. The first one of this part is the form and curve surface quality analysis. Through the study of many current curve and surface quality analysis tools, at present, the main method of analysis analyzing the surface quality district in the 3-dimension assembly are such as this: highlight analysis, co-virtual Colombo continuity analysis, local relation analysis, and gap and altitude difference analysis of the nearest point. The surface quality analysis tools, based on illumination model, has good physical meaning and intuitive observation. It is a very important way of surface quality analysis. On the basis of which many analytical methods and theories has been formed. Among them, highlight line analysis is a very important analysis method in illumination model analysis. There are four main forms of highlight line analysis, such as reflection line, projection line, inarc line, and reflection contours. When we conduct a highlight analysis, we can choose three forms of layout. The first one is created by the specific point. The second is select uniform intervals on the selected analysis surface. The last one is select a uniform interval between two specified points on the analysis surface. With these three forms of choice, design analysis can directly select on local area that they want to analyze, not necessarily to enter its surface. This is more efficient and faster, and can better analyze the surface change of curves and the surface. By the surface quality analysis, highlight line analysis, special tools, and set the parameters, selecting the surface analysis from according to the surface inspection requirements. We can use the 3 or 4 tiles just shown in the picture like this. By observing the reflection highlight line of the curved surface of the impede based on show the picture, the distribution of the line group is uniform and there is no duplicated reflections, which indicated that the design surface has good quality. In the same way, you can also use these three forms of projection line, isoline, and reflection controls highlight line to check the surface, and the inspection results can be computed. By the comparison, it can be seen that the highline of each form are uniform changed, and the above description surface inspection results are verified as shown in this picture, in these three pictures. The last one is the conclusions. My work studied the method of highlight line of curved surface quality evaluation based on three-dimension assembly environment. Analysis on the quality of the impure based on surface of the impure assembly parts through 4 forms of analysis. The results show that the distribution of branch line is uniform. This part of the design surface has good continuity and smoothness. In addition, the analysis of the method of highlight line of curved surface quality evaluation based on three-dimension assembly environment is intuitive, efficient, and accurate. It can also control the line source configuration and highlight line display by setting evaluation parameters. Through the appropriate secondary development by the user, a complex or special surface can be quickly modeled. Combined with the 3 coordination surface measurement, the surface quality of product design or application process can be analyzed quickly, find the defects, so as to improve the quality of the curves and the surface design. This is my work. Thanks you for your listen. Thanks, Professor.